Hey everyone, and welcome to this explainer. Today we are going on a seriously fascinating intellectual journey. We're going to look right past some of nature's most famous, easily recognizable patterns to uncover a hidden ancient architecture. We'll be exploring a really compelling framework put forward by independent researcher Antonio Victor Salas-Dual. He's bridged the gap between exact mathematics and paleobiology, and he suggests that a deep, underlying arithmetic code might literally be the unseen foundation of all plant life on Earth.
Now, for centuries, we've looked at the natural world with this kind of automatic reverence, right? You look at the stunning spirals of a sunflower, the scales of a pine cone, or how leaves are arranged on a stem, and your brain immediately jumps to one word: Fibonacci. I mean, the sequence seems to be literally everywhere, but here is the critical question we have to ask ourselves. Is Fibonacci actually the whole story? Or are we just looking at the highly polished final result of something much, much older?
Okay, let's dive into what Salas-Dual calls the Fibonacci veil. Think about a massive, beautiful skyscraper. When you look at the completed building, you don't see the cranes, the beams, or the scaffolding that actually held it up during construction. It's the same with nature. An adult plant doesn't necessarily show you all the underlying arithmetic roots that channeled its geometry to get there. The hypothesis we're exploring today suggests that while the Fibonacci sequence is the highly visible optimized form we see today, there might actually be a much deeper mathematical architecture hiding right underneath it, a foundational scaffolding that nature relied on to reach that perfection.
So to really understand this scaffolding, we have to establish the exact mathematical framework. Salas-Dual isolates some very specific branches from the classical Fibonacci and Lucas sequences. He calls these exact extractions FiboTeslas, which isolates the sequence at jumps of 4 indices, and LucaTeslas, which applies a similar jump but shifted slightly within the Lucas sequence. Now, he isn't just picking random numbers here. He is extracting them at exact rhythmic intervals to isolate a distinct internal mathematical network that runs on its own rigorous rules.
When you actually look at how these specific nodes are extracted, it's pretty wild. Jumping just 3 sub-indices in this new Tesla framework corresponds to a massive leap of 12 positions in the original parent sequences. It's basically like putting the math in fast forward. And again, these aren't just isolated mathematical tricks. This method essentially filters out all the noise to reveal a perfectly tuned parallel network operating seamlessly right underneath the growth of the original sequences. To really ground this, just look at the exactitude here. Both of these branches start perfectly at the number 3. And as they grow to 21, 144, 987, they stay completely anchored to real integers. There is absolutely no need for messy decimal approximations or rounding. It's just an incredibly clean, crystalline mathematical progression that functions flawlessly all on its own. Well, how do these sequences actually generate these numbers? They use what's called the 7 engine. Instead of just crawling along step by step like a standard sequence, these branches have their very own internal loop. The rule is simple but powerful. The next number is exactly 7 times the current number minus the previous one. So it's an entirely self-sustaining engine built on pure integer arithmetic. And this brings us to the famous 369 vibration. If you calculate the digital roots of these massive numbers, basically just using strict modular arithmetic modulo 9, they collapse into this beautifully disciplined repeating 6-beat pulse. What's amazing is that FiboTeslas and LucaTeslas share the exact same numerical ingredients, just with a shifted internal phase. They are locked together in this perfectly harmonized mathematical dance. So these branches aren't just running completely parallel to each other. They are intrinsically linked by what's known as the Salas-Dual Bridge. This horizontal algebraic link reveals something incredible. If you subtract the previous FiboTesla from the current one, you get the exact corresponding LucaTesla. Let that sink in. One sequence is literally defining the exact mathematical difference happening inside the other. Which leads us to the absolute core of this entire framework, the telescopic sigma equation. Mathematically, this proves that any FiboTesla is the exact cumulative sum of all the preceding LucaTeslas. So think back to our skyscraper metaphor. The LucaTeslas are the individual cumulative building blocks. They act as the ancestral mathematical scaffolding. Stack those LucaTesla blocks together, and they sum up perfectly to create the grand FiboTesla structure. Okay, let's pause and shift gears for a second. Up to now, we've been dealing with absolute, stripped mathematical proof, pure arithmetic. But we need to draw a boundary here, because this is where we transition into a rigorously testable biological hypothesis. There's no mystical physics at play here. The question we have to ask is, if this telescopic accumulation exists so perfectly in pure math, Could it actually explain how plant geometry evolved over millions of years?
And that is exactly Salas-Dual's paleobiological hypothesis. We know modern plants heavily favor Fibonacci geometry. It's a highly channelized trait during their development. But what if the Lucas sequence, and specifically these LucaTesla building blocks, represent the shared genetic memory and ancient morphogenetic spaces of the plant kingdom? Think of it this way. If modern Fibonacci patterns are the optimized software running the show today, then the Lucas architecture might just be the ancient hardware that made the whole system possible in the first place.
This concept completely forces us to rethink the fossil record. As Salas-Dual points out, and I love this quote, the past cannot be read as a simple, continuous line of Fibonacci from the origin. We really shouldn't be forcing ancient fossils into a modern Fibonacci mold when the evidence clearly shows us that the ancient world was doing something fundamentally different, yet incredibly structured way before the modern sunflower ever existed.
Let's look at some concrete evidence. Enter Asteroxylum mackie. This is a 407 million-year-old Devonian fossil. When researchers carefully reconstructed its 3D reproductive structures and leaves, they didn't find Fibonacci. They found rare, distinctly non-Fibonacci geometries. This fossil is basically a 400 million-year-old oracle. It proves that the ancient ancestors of today's plants utilized entirely different geometric pathways, validating the urgent need for us to use a broader mathematical lens.
And this poses a really profound challenge to the field of evolutionary paleobiology. For a long time, whenever a fossil didn't fit neatly into the Fibonacci sequence, it was often just dismissed as taphonomic noise, just preservational damage or evolutionary anomalies. But what if they aren't anomalies at all? What if these non-Fibonacci patterns are actually perfectly preserved transitional traces of that older competing Lucas pathway? We might literally be looking at the biological expression of the telescopic sigma equation.
Of course, any hypothesis is only as good as our ability to actually test it. And that is exactly what is proposed here for paleobiologists. It's a specific, measurable, and highly actionable program. Instead of just visually guessing or forcing a classification based on modern plants, researchers now have an expanded mathematical toolkit, using both the Lucas and LucaTesla frameworks to actively evaluate ancient plant fossils and test this ancestral hardware theory directly.
The methodology here is incredibly rigorous. First, you have to 3D reconstruct the fossil to separate true biological signals from compression errors or taphonomic noise. Then, researchers independently count the spirals without trying to force a match. That raw data is then compared mathematically against Fibonacci, Lucas, and LucaTesla sequences to find its true alignment. Finally, the data is published openly so the whole community can test and verify it.
So where exactly should researchers be looking to find this ancestral code?
Well, you don't look at modern seeds. You have to look at the tough, ancient structures that survive the fossilization process. We're talking ancient leaf scars, fertile axes, preserved cones, bracts, and sporangiation arrangements. This is exactly where we might find those hidden Lucas pairs, like 4-7, 7-11, or 11-18, literally recorded in stone, waiting to prove that the biological blocks of the LucaTeslas scaffolding are real.
The biggest takeaway from this explainer is really a call for scientific humility. We have to read nature without forcing it into the boxes we are most comfortable with. We have to measure its accumulated architecture rather than just assuming it's all Fibonacci all the way down. The Tesla matrix framework finally gives us the mathematical vocabulary to ask if life on Earth was actually built through a telescoping accumulation of ancient geometric layers. So I'll leave you with this final kind of mind-blowing thought. We now have exact mathematical proof that LucaTeslas act as the cumulative building blocks for FiboTeslas, and ancient fossils like Astroxylon strongly hint that nature actually utilized this very scaffolding. So if Fibonacci is truly only the facade, what other ancestral mathematical codes are echoing right now in the foundations of the natural world, just waiting for us to uncover them? Thanks so much for joining me on this explainer, and keep questioning the patterns around you.